Hello everyone and welcome to the May 14 Propeller Live Forum. We'll have a presentation from Steven today, and I just have, it's going to be a short meeting for sure after the Propeller day that we had at Parallax. If you miss the event, even online, hold on there. If you miss the event, we have a link that I'm going to share with you that has some videos and links to the recordings of most of the presentations. We didn't get all of them. I think we got about 8 of them and plenty of pictures from that day. I can actually open the link if Zoom is to collaborate. And the videos, you will also get to see some of the recordings from Friday with lots of students from local schools. And there's plenty of pictures there of that day. And I just share the link on the chat. If you're watching this in YouTube, you can go to Parallax Community News. When you go to parallax.com Community News, you will find this news post. And before we go into today's presentation, I would like to speak a little bit. Ken is not here today, but I would like to speak a little bit about the format of the Propeller Live Forums. It's actually not Propeller 2, it's just a Propeller Live Forum format in the future. At some point, we did some adjustments, some changes, and we are open for feedback from the community, whether you are in person here today or through email. We may as well run some kind of online posting to see where people stand at. But we would like to go to a more formal system of the presentations where we have some scheduled presentations, like we have Steven Morocco today, and then we do the official presentations. We stop the recording, we open for discussion, and that way we can have an open discussion more freely without the recording going to YouTube. And I would still like to see if we can cap the open discussion time, maybe 1 hour, again, open for debate. So we can, if there's any big subject that comes during the open discussion, we can actually try to do a presentation for the next time. So if there's a lot of interest on a certain subject, we can make it a proper presentation, a formal presentation for the following month, and we can record that presentation and post it in YouTube. Otherwise, it's very, very hard, even though we have Brian going through the recordings and trying to do an index of what we have, but it's like digging for gold, you know, trying to find those nuggets through hours of talking in YouTube. So we'd like to make it more useful, like it was in the Propeller Day event. We have very specific presentations that we can record and share with everybody. And also, Chip is getting into too many projects, inside, outside Parallax, software-related demos, and some hardware, like the new module that will be more industrial. So we want to also make sure that Chip can, tackle all those projects without spending too much time in the forum, going sideways sometimes. So once we have those, we may have some projects that could be like brainstorming sessions, things like that. But once we have those ideas, we need time to get them done. So eventually, if you have any feedback, please send it by email to Ken or myself. I'm going to write a message in the chat, and let us know what would you like to see in this monthly forum events. So that's all I have for today. So Steven, are you ready to present? Or you are muted.
Oh, yep.
Okay.
There you go.
All I was saying was you probably have to stop your share before I can, so that wasn't important. You didn't miss anything. Okay, so let's see. What do we have today? Oh my gosh. Okay, fine. I've had too much. Let me get things out of the way here. All right. So, in preparation for going out to last weekend, or was it last weekend? Weekend before the group
It was the weekend before last.
before. In preparation, I worked on trying to get the 51 features released for Visual Studio Code. And so I got a couple of releases out. Since then, I did a couple more. So that's what we're going to talk about. Is these were my announcements in the forum post. Visual Studio Code. What we're talking about is in the Visual Studio Code marketplace, you can download this Spin2 extension, and it supports both P1 and P2. It has syntax highlighting, semantic, and you probably all know that. I'm just showing those who already know. If you go to the repository, then you get this as the README and a whole bunch of links for setting it up, how to set up tabbing, how to set up the various different coloring forms, and then how to set up builds as well if you're going to build from within Visual Studio Code. The tool set is just getting better and better, and that's what we're going to look like. Is what is the current highlighting. Visual Studio Code, I tend to run dark theme. You can choose whatever theme you want. There are 4 different themes supported. When you're in Visual Studio Code, the extension looks like this. If you were to search for it, you'd see this. If you didn't have it installed, I'm assuming you can see this. I am screen sharing. Yes, good. Okay. Let's look at what's being shared, Steve, so you have an idea. Okay. If you're in Visual Studio Code and you click the extensions button, then you're going to see this. If it's not installed, you'll see an install button. So mine is installed. If you click on it, it just tells you what version you have. You can see downloads and things. And then I always set the color theme. And the color theme I'm using is dark. You can see that I have 4 different types. If you're using the color backgrounds, like we have in Propeller Tool or Spin Tools IDE, then you use the 2 light and dark for the background color. Otherwise, you just use light and dark. I'm going to stay in dark for now. That's it for the intro. Let's look at some code. What does it do? When we have code, it color codes the various different elements of code. And in the case of constants, they're showing dark, violets. In the case of objects, they're blues. And we have different kinds of variables. So the instance variables are kind of greenish hued. The variables that are available to all instances are kind of bluish. And then, of course, we have variables on methods. The locals are lighter green, and parameters are kind of pinkish. And we'll go over more of that. But just so you can see, the method calls are yellow when you see built-ins. And if you hover over the method calls, for instance, it tells you about that method, what parameters, what return values there are. And so there's built-in help for when you're using Spin.
Hey, Stephen.
Please, go ahead.
You know that little bubble that appears, that thought bubble that appears when you hover over something?
Yes.
Is there a way to make its background like a opposite shade so that it jumps out from the text? Because I had to, when you were showing that a minute ago, I was looking and I couldn't really, I had to look and read the text to know, oh, that's the message.
Right.
It kind of like,
not that I'm aware of. We are a victim of how the designers want Visual Studio Code to work. What I'd like to see here is for colorings of things to be controllable, and theoretically,
right.
text colors are controllable, although I haven't been able to determine how. You can see some things get colored correctly and some things just don't get colored. I'm sure this is partly controlled by the theme you're running. And if I find a theme adjustment that lets me specify those, I could go to a more distinct color background.
Right.
I haven't found it yet, so good question. Let's see, round, another built-in.
Hey, one question. If you pick, say, a colored background, do you still have the colored backgrounds possible, like the lighter ones?
You mean go to the Spin Tools coloring? Yes. Yes.
Okay, in that case, does the thought bubble kind of like differentiate from the background at all?
It's also going to be annoyingly similar to the background.
Okay.
When you're adjusting your IDE, settings, extensions. These are all the extensions. I have way too many installed. Scrolling down to Spin 2, you can see all the settings for the Spin 2. And so now you can go through how do we adjust the Spin 2 behavior. And this is how you turn on the Spin 2 coloring. And I would turn this on, and then I would go change my color theme to make it work better with the light backgrounds. Let's see here. If you're using FlexSpin, and that's your preferred environment, you can turn on FlexSpin in capabilities, and it changes the validation behaviors of this system. Various different, we can talk about some of these later, but there are lots of settings. This is editor and tab stops. This is insert mode with insert overtype, align that you see in Propeller tool. This is our tool chain. So you can set it up to run with FlexSpin, Peanut TS, or Peanut if you're running on Windows. And this is then the build environment for which compiler is currently seen in the environment is selected. This stuff is maintained automatically when you're running and building. So this is the last one that you actually configure. I'll get away from that. Okay, so when I'm releasing a new version, I have these canned files that I go back and check and make sure that everything's highlighting correctly for these different forms. Strings are kind of red, built-ins are different, assembly language built-ins are different colors. Data storage types are the darker green. When they're used, when these words are used as data storage types, they can also be used as size directives, in which case they'll be light or violet. Again, I'm just walking you through so you can see some of the differences. If I'm going too fast, let me know. These are highlighting file names that are actually brought in as objects. You can see the constant overrides. Methods and how they're colored. And so you have public methods are lighter, private methods are darker. So you can see those. Let's see. Here's just another file I used to go through all the different parts. And then variable blocks, var blocks. And you can see the alignments have a different color when you're specifying them in here. Let's go through language parts. Let's go now. Here's where we start seeing some of the new code. We turned on the different version specifics. And so this is the case where Johnny Mac, you saw the new layer and crop directives. And so these in debug statements, these are now highlighted correctly. Let's see here. Version 45, we introduced some pointers, and so you can see a pointer to a long being passed here. And then we see various different pointer manipulations happening here. And you can see that we have the packed ASCII as a constant, where you're packing 1 to 4 ASCII characters into a single long. And so this is now even highlighted correctly as a literal value, a numeric value going in. Return values, local variables, so you can see the mixture. Okay, what else is interesting here? Maybe not much. You can see that we defined a scope display. We called it S. And then S, we're passing a string and configuring it for auto scaling. And then we started to S the display, we started passing values to the scope display. All right, 46, we have the new CZ flag for debug. That's highlighting correctly. Debug mask was introduced, and the new debug mask enables. So in this case, bit 0 and bit 2, I think, would be enabled, and so the 1 and 3 would not be shown with this mask in debug. Here we see the new task methods and how they're being used, and they're all highlighting correctly. So you can hover over them and have the built-in text. Then we see version 49, we introduce structures, and here it gets kind of even more colorful. We already saw that longs and words and bytes are colored as a data type. Here you see that as we define a structure, it's also colored now as if it were a byte word or long. It's a data type. So I'm declaring square, which consists of points, and point is declared here as X and Y. And point can also, my local structure can also be declared as a structure coming from the M object. So you see that stepchild actually has a public point structure, and that's actually being shown as coming from the object named M and assigned to the local name point. Here you see in the go method, you can see I can use either directly from the structure, the LA object is a structure, and LB object, local A, local B, local C, in this case, in my terms. Here's the polygon structure, which is nothing more than an array of points. And you can see then that I validate this is the local variable, but it also validates that .x is a structure member. And so they're all highlighted here as the local variable color. That takes care of that. Let's go to 50. Now we see some new things. Here we see the ditto commands being used in 50 and how they're colored. Here we see the new escape strings. And I went so far as to color the escapes so you can see them in your string. That was wonderfully entertaining. So that's all there. What else do I want to say here? Nothing much, I guess. Ditto is supported in both DAT and inline PASM. So that's what that's showing here. Chip, we're going to wander into some of your code because that got really kind of fun. And so here we see a little bit more advanced. Well, I'll go to this one first. Here we see a quick math library that Chip did and how it's colored. Defines its own 128-bit structure as an array of 4 longs. As methods, it uses a structure. And then here are the calls for it.
You know, yesterday I went into this and all those orgs, I could change everything that doesn't loop. I changed to an org H because there's no reason to buffer it up if it's not going to loop.
Yes.
It just runs once. So I saved a bunch of memory. And then I started implementing some that like modify the variable by passing them a pointer to the, like if there's one I made where I want to sum values into some kind of accumulator.
Sure.
So I just pass it the pointer and then it works on the variable directly.
So if I'm hearing correctly, what you're reminding us of is that when you do an org, this block of code is copied into a cog and run. When you do an org H, you're going to run it directly from hub memory instead.
Yeah, and it's just faster because there's no branching in there.
Yes.
So it runs faster than a cog because it doesn't have the overhead of having to load.
Right. So what you're saying is if we did any branching, we'd be required to move it into a cog
Well, you wouldn't have to, but you're going to suffer a loop penalty, you know, a time penalty on looping.
Your fetch penalties on hub memory access.
Yes.
Okay, good. Well, thank you. So you can see how this is all coloring. The PASM is all kind of a dark red color for instructions and for actions and for conditionals. Pretty straightforward there. You'll notice that, unfortunately, I haven't taken time to put all 300 so hover text instructions. Thank you. I haven't put all the instructions. It's my wife leaving for the Y. Sorry. Let's see here then. Let's go to 51, code that now uses this. You can see it's imported as Q. Here you see structures being declared. Here you see multi-line declarations of structures. Comments on the multi-lines are automatic after the 3 dots, but that wouldn't be the case here. So it's good that Chip just used the single comment directive on all 4 of these lines. Let's see, what else do we see here that's fun? Other multi-line code. Again, the coloring here. With this green color, we know that this M structure was declared in a var in the variable area. That's right here. So again, the variable colors that you're seeing in the instructions tell you where they're declared. In fact, what I'd like to do, I do tell you when you hover over it that it was declared as an instance variable. Here it was object public. Seriously, is that right? Interesting. Oh, it's public in this one. Yes, okay. Encode as an instruction. So all of this is here, and you can find out. Cycle was declared as just a parameter coming in. Okay, so it tells you these things. And there's the math 128 object is big. Let's see, what else do we see? Again, line continuation all handled appropriately. Anything else special? Line continuation here for local variables. Comments all being well behaved. That was an interesting challenge.
Hey, Stephen, I just had an idea. If you look at like this, oh, go ahead.
I was going to say one more thing first as a quick. One of the things I'm showing you with these colors is the difference between syntax highlighting versus semantic highlighting. I'm going to switch over to syntax highlighting only. And you can see that just recognizing names and what they're for can only be done for parts of your code from a syntax standpoint. The rest of it, you have to understand the context in which it's used before you can do semantic coloring. And that's the whole point of the semantic coloring section of this extension, is that we can understand what the meaning of all the different areas of the lines are, and we can color things appropriately. Okay, Chip, you were going to say.
Yeah, you see, you know how on the propeller tool we have little lines, like under an if or a block, we drop a line with little arrows to show the shape.
I have no control over it. I wish so badly that I did.
No, I know. I'm not complaining. I just had an idea.
Yes.
What would be even better than lines? Because lines get too persnickety to stare at. You know, they're kind of tiny.
Yeah, they're distractive. Yeah.
Like especially in the TypeScript stuff. I mean, there's like many little lines, but
oh my gosh, yes. In TypeScript, they do highlight. I wonder if I have show people what we're talking about here.
Because I'm just thinking that what would be really nice is just to like change the local background slightly to show scope, so that there's a bigger like visual thing to look at that is not so, you know, tiny, fine lined and everything. Yeah, like this is what we see in TypeScript all the time.
Yeah, so these are the lines we're talking about, the nesting that you have right here. If you're in TypeScript. And in fact, this is a USB method for talking to our prop ports. But you can see these lines here, they're different colored. That is a special extension that's coloring those. But I, again, haven't learned how to control that coloring. And so as soon as I learn how, then what I would expect is I want to set vertical lines on your tab stops because we have tab stop control. And that will help you make sure that these indents are all lined up where you want them to be. To answer your question, Chip, you're suggesting that we have vertical regions of coloring?
Yeah, well, no, I mean, like imagine, okay, see that right on line 151, there's an if not.
Okay.
And then there's a then there's this line that says debug that belongs to the scope under if not.
Yes.
What if the if not could be like accentuated in some way with some background color, and then a relative color would go for everything that falls under that scope. And then if there was a subscope beneath that, it would get some similar but different treatment with another color, so that you could like, rather than have to ever look at lines, the background would just show you who belongs to what scope.
Right. Let me do.
I mean, we've never done that, but I'm just thinking that anything to make it easier on the brain about what belongs where, because with indentation, things can really get, you know, if you're looking down a long bunch of text, like when I started writing the compiler for Spin 2 in Spin 2, And I had the whole tokenizer, the elementizer, down to like, oh, it was not even much, maybe 150 lines of code. But there was a lot of like indentation. And it would be neat if I could see, because I have to look very carefully, and I'm kind of scared if I, hit backspace once or twice in the wrong place, I could change the meaning of all kinds of code. But
Right.
it'd be neat to have it like really accentuated in a way where it's not hard for your brain to just go, oh, that belongs to that.
Right. So the challenge with this, and you can see these colors, I cut over my environment to the Propeller tool coloring. Light background version. There's the dark background version also. I also have CRLF or LF only marks here. That's what these are. Carriage return line feed shows up as these arrows. These color
Hey, you
regions.
just like reinvented the semicolon.
What? Where?
No, I mean with those little arrows are like semicolons in other languages.
Yeah, it's just a line end marker, special
I
expression
know.
that does that. Okay, so here you can see there are tabs in the files, and I have white space marks turned on. And what I wanted to say though, relative to your question, is every one of these colored regions is a declaration statement where I had to scan through the code, identify the start and stop of every one of these regions, and then specify a style for that region and record the entire list of regions at the top of the file as we loaded the code. So then as it was painting the screen, it remembered those region colorings and scrolls them with the text. And so there are what, 10 different, 12, 14, I don't know how many.
Oh yeah, there's 6 basic blocks, and then you have alternating colors. Like the prize there,
There are 2 colors
go
for each
between
block.
2 colors.
Right. So what I wanted to do is look at how many blocks we've got. We've got this many blocks. And so what you end up with is that many different color shades. Now, if you abandoned this coloring and then did something like yours, what you were suggesting, we'd have a different block color for every indent region. And it's feasible, but I couldn't do both at the same time because you don't have that many colors.
Yeah. It would have to be thought out.
Yeah,
And
exactly.
it'd have to be done in some practical way, but
Right.
because I had things that were indented and outdented, and the scope was kind of complex for me to follow, but it
Right.
could be easy if I had some kind of like obvious coloring.
Right. And so here to answer your question, what does the hover look like? It's
Oh, there, it's even way
different.
better.
It's different, but it's theme based, right?
And they're controlling it.
They're controlling it. When I
Looks like they have dark gray or light gray. That's your option.
yeah, it's not fun. It's insufficient in my opinion, but I can be pretty opinionated.
Yeah.
Let's see here. Okay, let's make things easier. Let me switch back. Go back to dark. Turn off our coloring.
Oh, yeah.
Settings. Spin 2. Turn off the coloring. Close down settings. And there we are again. So life is a little easier to, not as bright on my screen. There is also a dark mode pastel set of colors. Now, one final thought to your question and to the issues with this when we do the Propeller tool coloring. There are something like 16 different colors, or 17 or 18 that we're using so far. And finding a good color match that doesn't look terrible together and yet is each of the 16 are unique and distinguishable from each other is wonderfully challenging.
Yo, I know. Yeah, it's a hard thing to do.
I have color palette tools that I use to help me do that. And in fact, in the latest passes, I'm even starting to use the AI, the Chat GPT resources to help it study and refine my colors. And so if you see these get a little bit more refined over time, if I can suffer the changes myself mentally, I might change the colors and come up with something that's a little easier. But we have a couple different things we have to look at when we look at this. I don't know if you can see this, but this is a bold version of this. Same color, but the constant definitions are bolded.
Okay.
Same thing when you're doing variable definitions. The definitions themselves are bold. When you're defining the parameters are bold. The definitions, the use then is not bold. Okay, so there's just a tiny, tiny distinction there: big, fat, fuzzy characters versus non-bold characters.
Yes.
So I'm using bolding, and I'm using the 16 or 18 different colors to do all this. Let's see. For user-defined variables, if this had comments with it, if driver cog had, if I were to put comments out here, you see it telling me what I should be saying here. That's actually my Smarty Pants Chat GPT sitting beside me. And
It can even complete comments.
yes, it does it based on the style of comments that you do, which is just very weird.
Wow.
Now I wanted to see if my highlighter will actually pick that up. Yeah. So you can see if you declare variables with comments, it's going to put it in your hover text. It finds them in two ways. It can find them above the variable, and it can find them to the right of the variable. And so just to let you know, if you want to document your code, you can do things like that.
Can it just make comments for your code?
Can it just make it? What do you mean?
Can you ask it to just comment this code?
I start the comment and it says right there,
Well,
that's a totally made comment, and I have to approve it being used. Okay, so all I did was type in the tick, and it says, how about if I write it? How about if I write it that way?
like auto completion for your thoughts.
Exactly. So, you know, it doesn't do a terrible job, but these names are similar enough you don't need these kind of comments, right?
Right.
And so they're kind of, I just want to see where it's going. For binning, if that's an interesting term. Is that more English than American? For binning iteration counts?
For binning iteration counts.
That's
No,
an interesting term.
I don't know. Did I write that comment?
No, you didn't. I'm seeing what Smarty Pants is doing here.
Oh, that was, yeah, for bin, that's what it was doing. Yeah, it was binning iteration counts. Yes.
Right. So now I wanted to show you, suppose that Chip actually wanted to document this code. There we go. You just write the description of what the method does. You describe each of the parameters. If you're so inclined, you can also describe why the local variable is being used. And when you hover over it, this much of it will show up in the hover text. All right. So that's whether you're hovering over it in this. It's griping at me because there's nothing there yet. But that's whether you're using it here in this file or whether you're using it in a parent object. It'll show up. So,
wow.
just to let you know, Studio helps us, Visual Studio Code, the way I've written the extension, helps us do all this. Okay, what else do I want? I don't want to save those changes, really. Can I back up? Thank you. So much backspace. We don't have enough backspace in our life. Oh my gosh, I could have just quit. Okay, version 51, what else do we have? New operators?
Oh yeah, exponential and log operators.
And available in different areas, and they're all colored. Okay, can you tell me what, anybody in the group, can you tell me what this one means? I know Chip does. And why is that green? Caught you by surprise, maybe. That says we're returning a structure, and it's labeled X. X is construct Y. That's the line it was declared.
Oh, it has 3 longs.
And so that's X. And here also, it would be returning the structure, and we're ignoring this return structure. It's 3 longs. We tell it it's 3 longs. So when we do this ignore of the return value, it's ignoring all 3 longs. And so you can see the structure type is being colored. It's hard to see with only single letter variable names, but
Right.
that's what I have right now. All right, so that's the end of the show there. Let's go to one more. Just to show you how well we color debug. All the different debug display types are kind of shown here. And you can see how it's all being colored. And it exists in after inline code there. I don't think I've got anything in DAT code, but we can do the same thing in DAT. Okay, I think that's about all I have for to show off today. Is there any, does anybody have any questions? Is there anything else you'd like me to demonstrate? And this is,
Hey, Stephen, for me, I think we talked about this, but I have visual code set up. So all I have to do, will it update automatically to the latest, or do I have to go in and tell it to update?
nope, good question. Let's go over here to, this is the extensions tab. And you can see that when I select on this, see the auto update?
Okay.
Make sure when you select it, just set it to auto update, and from then on, it'll pick it up.
Got it.
It used to pick it up automatically. This auto update is new. And so I have no idea why they decided not to auto update things, but that's what that's about. All right. Any other questions? Thank you, Chip.
Thank you, Stephen, for showing us that.
You bet. It's come a long way.
Oh, yeah.
You
didn't even talk about the compiler at all.
No, we have Peanut TS version 51 is out. Let's see. I just wanted to show you there are other nice things. So just so you see how it picked up the typing suggestion for me. This one first says that Q isn't defined. I decide that I want it as a local variable. It says, well, I already know of it being used spelled like this. And so I just said, yeah, go ahead and complete it as that. So there again, that's Copilot helping me out. The red stuff is my extension. Actually saying that you're trying to use a variable that I don't know anything about. So as you're typing, it's reminding you that these variables don't exist, or you changed the spelling of something and didn't change it down here, right? And so you'll get pre-compilation help that had you let that go to compile, it would have just failed to compile. Another part of the extension. All right, I'll call it here then. Thank you, everybody.
Stephen, I got one question for you.
Please, please.
Those version files that you're referring to on your Explorer, are those in your Iron Sheet GitHub?
The version files.
Well, the all the spin2 files that you've been talking about that refer to your versions.
Yes. Okay. Let me show you what it is. The answer is yes, it is in the extension. I checked them in. It's under the test language server. But what are they really doing? What they're really doing is I put the version number in here on purpose to remind me that I've got a directive up here. So for instance, and this isn't perfect yet, but if it was an earlier version or didn't have a version, then these don't validate correctly. It doesn't know what these are. And so you have to put it at 47 for it to understand that, oh, that's a legitimate keyword in the language. So to answer your question, yes, they're in the repo if you needed to see them. If you need to use version features if you know you're going to use these features, then you'll see in the documentation, how quickly can I get to it? Not very. In the release notes for the spin language, the talk and drive the mouse at the same time. Steve, can you do it? Okay, in the release notes of the language, you see the releases here. And if you're going to use something that's required, you buy that version or later, then you can go ahead and put the directive as a directive for tasks. It's 47. And so you can put the spin2 directive right here in your file, and your compiler will then enable that support.
But no, I meant those actual, the code that you have in your Explorer, are
Yes.
those in your GitHub as a reference for, so I could use, so I can go through this
Yes.
video again? So
Yes.
that is in your GitHub.
Yes. And let me.
I'm looking at your GitHub here. Like, is it your?
It's in the extension GitHub, because these are regression tests
Okay.
for my extension itself. And I use the term regression test loosely. It's not automated in any way, shape, or form, because I have to visually check these things out.
Okay, I found it.
And so what you should find is in spin2,
Right.
test language server.
Yep.
And now you'll see spin2.
Yep.
Then you see language version parts, and there are the files that I just demonstrated.
Got it.
Okay, does that help?
Thanks a lot.
You're welcome. Okay. Any other questions? Well, I thank you all for your time today.
Thank you.
Thank you, Stephen.
Mm.
Chip, do you have anything else, or we open for discussion?
I don't have anything. I've just been finishing up Doug's stuff for the motion control. Let me see if I can. There's one thing I did. Okay, let's see. I can share my screen for a bit. You know what? Let me use Steven's colorizer to make this decent looking.
Uh-oh.
I type in VS Code period. Is that what I do, or code period?
Code space period to open up in your current folder.
Okay. All right, and then let me open up the here we are. Let me see if I can get the part of interest. Oh, you know, something's not, oh, it's not knowing something. It's like putting a lot of stuff in red. It's like putting structure members in red. Oh wait, I gotta also set the spacing here. Let's see. Spaces are
Zip up your files and send it to me, and I'll double check, Chip.
okay. Yeah, I'll do that a little
The only
later.
requirement is that the object files have to be in the same directory for your children objects, which is true for the compiler too. Is it does look in the same directory for the files.
Okay. All right. Well, let's see. How can it? Is there a mode where I can ask it to be less smart at the moment?
Not really.
Yeah, because it thinks that. Okay, well, I'll send these to you.
That's interesting. I should.
Well, here, I'll show you what it's.
It's going to be a mess, probably. When it goes wrong, it does go horribly wrong.
Well,
the other thing
maybe we can figure out. Maybe we can figure out what the trouble is real quick, or you can at least posit, you know, what it might be.
Sure.
Okay, let's see. I'll try to share my screen here.
Let's see. Windows. I don't think Windows is case sensitive for file names, is it?
Okay. Can you all see this?
Red, yeah. What's going on here? Yeah, it's pretty narrow, but I can see it.
Let's see. Let's see. What do I do to make my text bigger or smaller?
I think it's plus, Command plus or something. Control plus.
Control plus. Let's see.
Can we turn off warnings? Let me ask that question.
Oh, you can see what it's doing though, right? Oh, it's not seeing. Okay, it doesn't know.
It's not seeing your M file, it looks like.
Right.
Where's your org line for M?
Right up there at the top.
You have version. You have Q, but what's M? Oh, M is a structure. It's the same file I was using. Why is yours having problems? You're not updated, I'll bet. let's press, see this, see, I'm clicking on your screen. Go down to the squares one, that one.
Right here.
Yeah, go there. Now type in spin 2 at the top.
Is there, will I find it down here? There, this here?
Yep, reload required. See that? Go ahead and reload.
Oh, good.
There.
Right on.
Maybe there.
Oh, okay, excellent. Okay, so that's
better.
okay, good. So I'll go
Now,
down.
you still have some missing. There's a head variable that didn't go right.
Yeah, there's also a tab problem. Wait, spaces 2. Oops, hold on.
Yeah, display
I
tab.
wish it was possible to just tell it.
Change tab display size, set it to 8. Yeah, there you go.
Okay, there. Now we're looking at the right code. Okay, so
do you have it intentionally very narrow?
well, my monitor's on a portrait display.
Okay.
Is it okay? I mean, I could go like this. You could see more.
That's fine.
That's too small, probably.
It's too small.
Okay, hold on. We'll just forego reading the comments, but anyway, this is the motor control loop, right? Which is using the NCOs to generate the step signal for a whole bunch of steppers, or they're actually servo motors, but you talk to them with a step and direction signal. But they have their own internal PID loops to keep up. But I still have to observe, like, this is all jerk based, so that integrates into acceleration, into velocity, into position. And what I did in order to using the NCO mode of the smart pins was a real win, because now I can reduce my update time down to a millisecond. I don't have to be Johnny on the spot with every single transition to the step signal. But what I did here, this is real important right down here. Oh, by the way, this had been written in assembly. I mean, all this was like an assembly loop right here, right? And it was kind of big, and it was done with, because when you get into PASM, you know, everything is like the performance is highly implementation dependent, like how you code and how you arrange your problem to get a good solution.
Sure.
So it can drive you nuts if you're OCD at all, because you want to make it right, but there's just so many ways to improve things that you can. I mean, there's just all these optimizations you can use. But what I did here was it was getting so hard to think about, because I had to add some features in, and I didn't want to have to, like, you know, see all these things that use like structures.
Deep structure.
Right? Lots of structure stuff in here. And so the way I had to do that in assembly, I would put like a base pointer to each of the structures, and then I would index in as far as I needed to go. But I'm having to compute in assembly all these offsets and indices and all indexes and all this kind of stuff. And it was just getting to be really just too much code for what wasn't the matter at hand, you know? So because this whole thing only needs to run every millisecond, it only takes like 50 microseconds to run this whole loop. It's not much at all. Anyway, I just figured this is making me nuts. So I have enough time. I'll just recode it in PASM, or excuse me, in Spin2. And it just got a heck of a lot simpler to deal with. So this used to be an assembly, but now I get right to the point. The Spin2 can show you you can suss out the ideas without having to look at so much instruction, stuff just to get one simple lookup done. So now we get to work more at the higher level, which is better. But anyway, this business down here, I had asked like Chat GPT. If I had thought about it, I probably could have figured it out, but I figured it would have an answer, which it did. Actually, it had about 3 answers, and one of them was the right one. But my question was, when I run this NCO, I only have a 32-bit register that gets added each time. Each clock, the 32 bits gets added into the accumulator. And what about the fractional part? Like, what about all those bits? Because I'm using 128-bit variables to exactly track position, from jerk all the way out to position. And so all these integrations occur, and there's a lot of bit growth. So I was worried that, if I run the NCO, how am I going to account for the fractional stuff? So the trick is, here is my NCO value, right? See that? That's pretty high up. Amid this 128-bit number, that's 32 bits higher above this. So this is the fractional part, or the first 32 bits of fraction. And then this is the 32 bits of whole number right here. So what we can do is take this business, I'll call it NCOS. I forget what S means, sub. It's sub bit range. And so what I do is I have a running fraction called NCOF. Oh, I like how you like highlighted words.
Yeah, that's built
It's
into
really handy.
built into VS Code.
Nice. So what I do is I just take the fractional part, the sub part, I add it into the fraction, and then I just do an add x, into my main value, comma, pound zero, but basically say, if the carry set, increment it. And so by maintaining this and then feeding it, every iteration, every 1 millisecond, updating the NCO with this new adder value that might be 1 greater than it seemed to need to be. Over time, you track all the sub bits to another 32 bits below, and it really works great. I mean, I don't, it was really accurate to begin with, but now it's like super accurate. So anyway, it was just this code here. I take I get my fractional value into a register, what's going to be a register in assembly language, get the sub bits, the whole bits. Then I do a little inline assembly because you can't really do more than 32-bit math in Spin 2, right? So, we needed to know, did we overflow? If we did, increment the whole value. And then I put those back into the structure.
Sweet.
And so, yeah, that not much code, but that gave me like the ability to really freely use NCOs as the step generator for these motors without worrying about precision loss over time that would be practical to worry about. It's so the error is so far down that we're never going to hit it. It's never going to bubble up to the surface. And then what I do at the beginning here, this is ugly. Let me scoot this over.
So go ahead.
What's that?
Nothing.
So at the beginning, here I initialize my smart pins, right? And then I get the time. And then every time through the loop, this has to happen in a millisecond. I grab those whole NCO values that were computed. I put them in registers so I can get to them really quick. And then I do this part in assembly using this org-h. First thing is you compute when's the next target clock period, and then you wait for it right here. So as soon as you hit this next bit of code, you are you're locked onto the the clock edge. It's just like hardware. There's no jitter at all. And so I put this here to signal that this is kind of a garbage line just for testing. It's just to signal me when do I start updating. It's right after the wait count. And then down here, I make it go the other way so I can see on the scope. And my duty cycle is like 2%.
Wow.
Well, no, it's 50 microseconds out of a millisecond. It's about 2.5%. Is that right? It's about a 20th. It's 4%.
A lot of idle time then. Good.
It's 4%. That's low. So then here in this ditto thing, I generate the code that then, oh, that scares me. Okay, I got to put that back. Okay.
Yeah. Drag and drop it.
I know. Anyway, so this gets repeated, so for each smart pin, it grabs here, it updates the NCO value. And then based on the sign of the adder value, it sets the direction pin.
Hey, try clicking over the line numbers and see if that helps.
Oh, yeah.
That way you don't have to worry about drags, and you can click and drag and it'll do groups, I think.
Yeah, that drag thing is like treacherous.
It is.
It's what my friend would have called a cannon pointed at the user's foot.
It is.
Anyway, so I do all the super critical timing stuff right here, and then after that, I just go into Spin 2, and I handle all my command processing and everything, and computation of any new NCO value for next time through the loop. And so this made this whole thing way easier to work on. So I didn't really need to be doing PASM for this, because all these structure accesses just made it too painful. And my idea, the important stuff was getting to be sparse when you looked at the code. But now the concept density is higher again now. So it's easier to work on.
And to remind us again, the interpreter is just going to do a call out. It's as if the code between OR gauge and end were a subroutine sitting in hub, and you're just going to call out to it.
That's exactly it. I mean, literally the interpreter picks up an OR gauge. Let's do it the safe way. The OR gauge thing, and then this is the next thing in memory in your compiled bytecode. So it just jumps to that, and there's also a word in front of the code that says how far do we have to jump around. So it actually executes, it calls the code, and then when it comes back from that code, it just advances the bytecode pointer by that word that preceded the code, and then here you are right here.
Sweet. Okay.
Real simple.
Nice.
And so that's what I've been working on, and I got to get this done. I'll have this done in the next day or two for Doug. The next thing I'm going to do is to control each of the motors. I'm going to write like a high level a multitask thing so that you can have a separate program for each motor, because every motor, sometimes the motors are coordinated, but sometimes they're waiting. He has to trigger conveyors and things and wait for limit switches and this stuff. So each motor has somewhat of its own life. And so I figured the best way to do that is let him write separate code for each motor and then tie it together with the multitasker. So that way we can get all that stuff onto just one cog. And I could even put this real-time thing on a 1 millisecond interrupt, have it, interrupt before and then do a fine-tune wait count and then do its thing. And then I could fit the whole thing could be happening on one cog plus the smart pins.
That's amazing. It's amazing. Okay, a little Visual Studio Code hint. At the top, you'll see that your file is that tab, and there's a circular dot in that tab.
Wait, what tab up here?
Yep, go up further. See the circular dot, the black dot? That indicates that your file has been modified. Go up a little bit and to the right.
Wait, I've got this sharing thing covering up my code.
Ah, you can't see it.
Yeah.
You can drag the sharing banner down over it, and then you probably see the tab. You can also make
it window smaller. Put it over here.
Yeah.
Okay, there. Now up here.
Yeah. Now there was a dot there. You must have saved or something. But when it's either an X to close the file, or it's a dot saying the file was modified and not saved. If it's a dot,
maybe just make a change. Just make a small change on that code, and the dot should appear, right?
Yes.
Okay, so I'll put a space right here. Okay, there's the dot.
Now, my point is, if you were to exit out the file and you don't remember what the change was, you did a save.
Well, I just did a backspace. I did an undo.
Oh, okay. Put it in. Now I want you to put the space in.
Okay.
Now we're going to close the file without saving it. There you go.
And what go up here and say close?
Oh, no. It's auto saving. Do you have something saving all the time?
No, I don't think so.
You're not pressing Control S to save it or anything?
No, I didn't do Control S.
Okay, type in the space.
Here, okay, now I took that space out.
There you go. Now, if you click on the dot itself, it's saved. What the heck? Something is saving your files.
No, it didn't save. See, it's still.
Oh, is it? Oh, okay. When you click on it now, it should prompt you, do you want to save it before I close it? If it were in fact modified, it would prompt you. And it just closed instead because it wasn't dirty.
Oh, okay. Yeah, it really wasn't.
Yep. So,
okay, so.
Anyway, just to let you know.
Okay, here we are again. Okay. All right.
Just little tricks of the trade. Sometimes I'll accidentally modify a file and I need to go up there and just tell it to close the file and don't save.
Got it.
That's how I do it. All right. Thanks, Chip.
Yeah, I have some little words. So Michael Mulholland is working on, we've just about got the schematic nailed down for that little industrial module.
Nice, P2I.
Yeah, so that's coming together. We were wondering though, does anyone have any knowledge about the castellations on those boards? Because someone sent us at Parallax, I should have brought it back home from the weekend before last, but someone sent us a really nice little PLCC 84 board they made for the P2, and it had these like really nicely, looked to me like heavily metal coated, external fingertips like this, that kind of simulate, or they function as the pins on a PLCC chip. So the circuit board becomes like a PLCC package. But does anyone know do you know who sent us that board, Ari? And I heard something like that PCB was $20. Does that ring a bell with you? Because Michael and I were he's going to look into like what the board cost is, but we don't know. I mean, not every board shop can do these, side metal coated pins that are going to they have to be protruding out. They can't just be flat areas, because they're like these little plastic fingers in the socket that these little springs sit behind, and the pins have to go in there to hit these springs. See, but these plastic pieces here, you can't get rid of them. So the PCB has to be able to go, each leg has to be able to go between those little plastic separators and then contact the wire spring on the socket.
Now, the signals being passed between the signal contact is between the plastic things. Castellation holes are generally where the signal contact is. It sounds like you're out of phase.
Well, yeah, on the circuit board, from the circuit board's perspective, you have to have these protruding fingers that go out and are metal coated right here, because that's what's going to contact the spring in the socket. And then they have to be separated because there's going to be little plastic things from the socket that'll separate each of these. So that the PLCC 84 PCB, in order to fit in the socket, has to kind of have the same geometries as an actual PLCC chip.
Yes.
In which case it has these gull wing pins that kind of come out of the package, go down, well, they're J-leads, and they curl under a little.
Yes. But castellations are just the reverse, meaning they're sucked in at the center of the
Yeah. Where we need the tips of these features side coated in metal.
Yes.
So if this is the edge of that circuit board, they have to have a good heavy metal coating out here, not down in here. They don't need it there. They need it right on the tips, because that's what contacts the socket.
I'm finding a number of pages talking about how to do castellation PC board design.
Well, yeah, but see, castellation is like where you have little recesses that are like half of a plated hole.
You want bumps instead, which is just the opposite.
Yeah, now someone had this board made, but it looked like it was some kind of special process. And so
what did the board look like? Was it had the inverse that you wanted?
Yeah, it had, I mean, these were all insulated in here, nothing in here. But the tips, like, from here, this was all metal coated, top, bottom, and edge and sides.
Oh, okay, yeah.
So it was some kind of special PCB process.
Okay.
But we were just having like a little reality check talk last night. Like,
good.
What if this board is like super exotic and we get, over a barrel with the price and limited vendors and all this kind of stuff? Then we were thinking, well, what then? If we can't, if the PLCC 84 turns out to be too tricky, then we're going to have to go with some kind of like, module where maybe sort of like this, but with like dual row headers, down the sides or something.
Well, a standard castellation
because
can be soldered.
Some people said to solder. Yeah, the whole point was to solder, but the shape that you are saying to connect with the socket sounds like the opposite of soldering. So
yeah, I mean, they could be soldered, but the castellation thing is like he's soldered on the insides of the half holes. They're metal lined. Yes. Then you got raw FR4 out here and here, and then this is all open. Anyway, he's going to look into it and try to do some stuff, because we were thinking we could go with like 50 mil dual row headers or something we'd have to really, we need to get the size, or excuse me, We've got to do something that's available to people easily and not expensive, not exotic. I mean, there are all kinds of mezzanine connectors we can use, but we don't want to burden people with stuff like that.
Oh, those are mess. Those are a mess.
Yeah. We've used them on our FPGA boards in the past. They work nicely,
Well,
but
now we have a member in the forum who's already built these boards.
yeah.
What did his boards look like with respect to those edges?
Well, I think we had, maybe if you find it on the
Forums.
forums, you could just share your screen and
I'm looking. Let me see if I can find it. No point in sharing the search. I think he called it P2 stamp, didn't he?
yeah.
Doing a search.
Here, P2 mini socketed module.
Okay.
Was it Mixter? Oh no, he just asked in a question about it. Oh wait, when did he ask that question? On
Okay,
5/8, a while ago, like a week ago.
Brandon has a post.
Uh,
Yeah, pins with fingers in between. Yeah, it's just you're 180 out of phase with the castellation.
Here, PLCC 80 socket usage. No picture on this thread though.
Where's the board?
I think it was Raymond.
Yep. I
What about,
have one of
I'm
Raymond's.
going to share in the chat.
What are you?
I just put a link in the chat to see that.
Oh. Oh yeah, okay, so this is, now is there a picture of his board here? Well, this is a long thread.
Yeah, that's the thread I was in.
Now, you said that in between you had like plastic, but I'm wondering, oh, I see the plastic that you say, yes.
Okay, I got a perfect, I'll share my screen.
Okay, well, you can see how he's doing it. He's not doing castellations.
Let's see
His
here,
intent. Look at the first post of that thread.
right here.
Yeah, there you go. So he's doing projected pins, not castellations.
Right, projected pins, yes. So, I mean, they were pretty cool looking, but this, I mean, I guess they fit into an array for fabrication on the corners, but this is kind of an exotic looking PCB thing. I've never seen something like this.
Right. The question is, where
You
did
see,
he?
it's all insulated between them.
He had them made. All it is traces out to the edge, and then the board cut away between the traces.
But how do you get, but see, we're not looking at a profile of this,
Right.
but the vertical sides of
And have the
those,
vertical edges.
the vertical edges of those pins
have to be
are metal coated.
Yes. So yeah, does he say which vendor he went with?
I don't know.
It would give you help because he did make.
I could back up here and, oh, Rayman did this.
Yeah.
So Ray Allen did this.
So he must.
Well, we're going to have to ask Ray then.
Yep.
Okay, well, that's simple enough.
Talk to Ray.
Talk to
He
Ray.
built a lot of boards, so.
Yeah.
Yeah, hopefully it doesn't add too much to the board cost, but you never know.
Oh, look, here's a, wow, here's a picture of it in the socket.
Right, and it's perfect. It fits beautifully.
Yeah.
Yeah, what I'm wondering is, some people were talking about the socket, some people were talking about soldering. That's where castellated is good for soldering.
Yes.
I'm
Right.
wondering that if you make it good for the socket, then it's not going to be good for soldering. That could be a problem.
I'm not sure that's going to be the case because the pins will still sit down on traces.
Oh, yeah.
It's going to be the same problem with your soldering it. You always tie down one pin, center the board, and then tie down the rest of them, unless you're reflowing the whole board. But
Oh,
yeah,
and
you certainly don't want to I would bet that you in no way want to incur the cost of doing two different boards, one castellated and one not.
No, no. Well, I mean, this can function
This'll
for
lay
soldering. Yes.
down on a board and solder in place quite
Yeah,
nicely.
it'll work just fine. I mean, it would work just as well as castellation, I suppose, if you get enough. All that surface tension when that solder melts is going to pull everything into probably. Well, if there's a little bit of vibration to overcome stiction, everything will pull perfectly into center.
Correct. Yeah, it'll still solder very easily. The socket is nice, and I like the way he did the extra holes on the pins, because that actually gives you a way to probe it without.
Oh, totally. Yeah. Look at that. He just put like resistor legs in there or something, and then.
Yeah, so you could just probe the pins. That's excellent.
Yeah. Yeah, that's what we want to do. We want to do the same thing.
And of course, there's always Werfel, dirty probes.
Yeah, well.
Thank you.
Yep. They've been around a lot of soldered things, I guess.
No kidding. No kidding. Any equipment that's used is going to look worn. It's life.
So we'll ask Charles. Am I signed into this thing? Wait, I got to sign in. Let's see.
That's always my question too. Very cool. Very, very cool.
Okay, so we'll just say
it's going to be fun when we get these things.
Ray. His name is Ray, right?
I think so. Ray, man. Does he ever sign anything? It's Ray's Logic.
Ray. Okay, yeah, Ray. Oh, I'll just PM him. Well, no, I'll just ask so everybody can see. Ray, could you please help us?
Yeah. Who did you use to fabricate the board?
I'll use your term here, projected pin PCBs.
There you go.
PCBs.
Finger pins.
You did a great job on this.
Yeah, blindly doing a castellation would have hurt badly.
Yeah. Okay, so I'll stop sharing.
Cool.
Right, any more questions? Or we go into open discussion? Nothing. Okay, let's go into open discussion.